In this lesson, we're going to talk about rationalizing the denominator. So what rationalizing the denominator is actually doing is, well, it's the process by which a fraction is rewritten so that the denominator contains only rational numbers. And basically, if you remember back in a couple sections ago, we talked about the rules that are are needed to be satisfied in order for a radical to be simplified. Well, before we focused on rule 1. Now we're going to be focusing on rules 2 and 3. So let's go ahead and review those rules here. Just as a review for number 1, we already talked about this when we simplified radical expressions. The radicand has no perfect square factors other than 1. So that was basically when we took a number and we broke it into, square root of 2 and square root of 25, and we were able to simplify that down. Now, we're going to be focusing most of our attention today on 2 and 3. Number 2 is the radicand contains no fractions. So, for example, you're not allowed to have anything that looks like this, the square root of 2/5. You're not allowed to have fractions like that underneath a radical. So I'm going to show you how to eliminate that. And then number 3, no radicals appear in the denominator. So you're not allowed to have something like 5√6. And I'm going to show you how to eliminate that as well. So let's go ahead and look at a couple of problems. Okay. First thing we need to know is this thing called the quotient rule. It's very similar to the product rule that we learned about in the last section, but this is going to be working with division. So what the quotient rule states is that if you take the square root of a and b, it can be broken down into root a divided by root b. So basically, it's just kind of taking that root and splitting it into the top and the bottom. So that quotient rule is key for doing these types of problems. So let's go ahead and simplify the radical expression here. We have root 12 divided by 5. So unfortunately, it does not satisfy rule number 2, where we have a fraction. So we have to eliminate it. So we're going to start eliminating it by doing the quotient rule. I'm going to start by saying, okay, actually that's going to be an equal sign. And we're going to set it equal. We're just going to kind of break it down and say, okay, well, root 12, we're going to put over root 5. We just did the quotient rule, just split it up. Now we're going to do something called rationalizing the denominator. To rationalize the denominator, we're going to take that denominator because obviously it does not satisfy rule number 3. We can't have a radical in the denominator. It's okay to have one in the numerator, but since root 5 is there, we're not allowed to have that. So by rationalizing the denominator, I'm going to multiply the top and the bottom by that denominator radical. So let's see what happens here. Try to stay organized with your work here because it can get a little sloppy. All right, so in the numerator, if I remember the product rule from the last section, I know that I can take root 12 and multiply it by root 5, and that will give me root 60. And in my denominator, you have to kind of think about it. Root 5 times root 5. Well, root 5 times root 5 is actually going to just give me plain old 5. Okay, now that I'm to this point here, what I need to do is I need to take my numerator and I need to kind of go off to the side. And I like to call this a hiatus. I need to just take a little break, and I need to take root 60 and I need to simplify him down. So luckily, we're really good at this point because we've been using it in multiple sections. So what we're trying to do here is we're trying to simplify root 60. So you're looking for numbers that, factors that are perfect square numbers. So go ahead into your calculator and go to your y equals, and go ahead and put 60 divided by x. And you want to find your two factors. You might already know them at this point, but it looks like I come up with 4 and 15 are my factors. And there's multiple factors. I just picked this one because it was a nice perfect square value. So the square root of 4 is going to be 2, and root 15 does not simplify, so I'm going to leave it as root 15. All right, so now that I have my 2 root 15, I'm going to go back up and I'm going to replace it. I'm going to replace the root 60 with that 2 root 15. So I'm going to say 2 root 15, and I'm going to divide it by 5 since that's my denominator. Now, the last thing you want to check for here is, let me change my pen color real fast. You want to check your coefficients. You cannot simplify your radical number. So you can see that I have the square root of 15 and then 5 in the denominator. They're not like terms, so you can't simplify those. But if you look at the 2 and you look at the 5, if those numbers are able to be simplified, you want to simplify them. For example, if the top number was 3 and the bottom number was 6, you would of course simplify that to 1/2. But in our case here, it's already simplified, so we don't need to actually do anything. We're pretty much done with this problem. So your final answer here will be 2 root 15 divided by 5. So therefore, we've satisfied rule 1, 2, and 3. All right, let's try another one of those. All right, in this second problem, you can see that rule 2 is already satisfied. We don't have a fraction underneath a radical. But rule 3 is not satisfied because we have the radical in the denominator. So I'm going to go ahead and I'm going to start by rationalizing the denominator. I'm going to go ahead and put root 8 and root 8. That's how you rationalize. Okay, now what I'm going to do is I'm going to use the product rule and I'm going to multiply the numerators. So root 6 times root 8 is going to give me root 48. My denominators, root 8 times root 8 is going to give me plain old 8. And let me just make a little note on that. Let me kind of come up here and kind of explain why that is. So if we have root 8 times root 8, if we do the product rule, root 8 times root 8, that's going to give me root 64, isn't it? And the square root of 64 is a perfect square, which is going to give me 8. Now, you don't need to show you what I just showed up there, but that's why we can do that little process there. Okay, now that we're at root 48 over 8, let's go ahead and take a little break here, and let's go and simplify root 48. Go off to the side, and this is where you can go in your calculator and figure out your factors, and you're looking for nice perfect square numbers. So I see that I have 3 and 16 that I can break that into, which is going to break into 3 and 4. So when I break that down fully, your answer will be 4 root 3. So I'm going to go ahead and take that number, and I'm going to take it up, and I'm going to replace the numerator. So I'm going to say 4 root 3, and I'm going to divide it by 8. Okay, now this is the perfect example where we actually have to do some simplifying. So take a look at my coefficients. I have a 4, and I have an 8. Obviously, I can simplify those down, so I'm going to go ahead and do that. And I'm going to simplify that down, and it's going to look like this. The top is going to be a 1, and the bottom is going to be a 2. So really, I don't need to write that 1 up there because it's a coefficient, and I never really write coefficients of 1. So my final answer will just be root 3 divided by 2. Okay, let's bump it up just a little bit. Try a couple more problems here. All right. Here we have another situation where we have to satisfy rules 2 and 3. So I'm going to start this problem by rationalizing the denominator. So I'm going to multiply by root 15 on top and root 15 on the bottom. So if you remember back in the last section where we talked about operations with radicals, if you remember, we multiplied the 2 root 25 by 15, and you have to take the roots and multiply what's underneath them. So what we're going to do is we're going to take that 25 and we're going to multiply it by 15, and that's going to give us our root. So the numerator is just going to equal 2 root 375, while our denominator is just going to be 15. Okay, so now that I have everything broken down here, I'm going to take my numerator and I'm going to bump it over to the side. Now, there's two options you can go and do here. You could take the 2 with you, or you can deal with him whenever you get back after you've simplified him. Personally, I like to take him over with it, just so I don't forget that he is still there. So I'm going to take him over, and I'm going to put a multiplication sign, and I'm going to go ahead and simplify him just like I know how. So I'm going to go to, this is kind of a big number, so it's 375 divided by x, and let's go ahead and find a nice big perfect square number. It looks like 3 and 125 is the winner. No, I'm sorry. Oops, second grab. 375 divided by x. Let's go ahead and see here. Any nice perfect square numbers? I thought that was 225. Looks like we have 15 and 25. There we go. So here's what I'm going to do. I'm going to say 2 times, and then I'm going to break him into 25 and 15. Keep simplifying. 2 times 5 times root 15, which gives me 10 root 15. Okay, so that is the top, the numerator simplified, including that 2. So I'm going to go ahead and replace that whole thing. I'm going to say 10 root 15 divided by 15. And you can see here that my coefficients in the front are not simplified, so I'm going to go ahead and simplify them. 2 root 15 over 3, because 10 divided by 15 is going to give me that 2/3. And you are fully simplified. All right, let's try another one with a variable, kind of throwing one in there, and we'll get a little bit more complex as the unit goes on. But let's go ahead and start this one, and let's go ahead and rationalize the denominator. Let's go ahead and multiply the top and the bottom by 27. And let's go ahead and use our product rule and go ahead and multiply these straight across. So it looks like I'm going to have the square root of 297 with a y. And then in the denominator, I'm going to have my 27. All right, I'm going to take my numerator and I'm going to go off to the side, and I'm going to go ahead and simplify this. And if you remember, when we dealt with variables, we first started by breaking them up, and we said, okay, root 297 times root y. And we kind of started there. So let's go ahead and figure out 297. Let's go ahead and figure out some nice perfect square numbers, see if we have any. What do I see here? Oh, I see one. 9 and 33. Kind of hard to find. And if you remember, y, the square root of y is just going to be the square root of y. So let's go ahead and simplify this down. We have 3 root 33 times root y. So we're going to piece this all together, and I'm going to say 3 root 33y. And that's going to be what I'm going to go ahead and replace in the top. So I'm going to say 3 root 33y divided by 27. Obviously, you can see that 3 and 27, they're going to simplify. So I'm going to go ahead and simplify that down. My numerator will be 33y, and my denominator will be 9. And at that point, you are fully simplified. All right. Let's keep bumping it up. I think these are my last 2 examples for you. But let's go ahead and try some more difficult ones. These are ones with variables and just some good stuff. So in our first example here, you can see that our rule for our number 2 rule is not satisfied here. So we actually have to go ahead and use the quotient rule. We have to break this up. So I'm going to break it into 26x squared. I'm sorry, not squared, to the 6th divided by the square root of w to the 4th. So I had to do that step first because now I don't have a fraction anymore. So now I'm going to get rid of my denominator, and I'm going to do that by rationalizing the denominator. So I'm going to multiply the top by root w to the 4th, and I'm going to multiply the bottom by root w to the 4th. Okay, so let's see what that simplifies out to. And take your time with this. We know that the denominator is easy. That's just going to be w to the 4th. But the numerator is a little bit stranger. So we're going to use our product rule. And we have our coefficients of 26 times 1. So that's just going to be 26. So I'm going to have root 26. And then I'm going to work with my x's. Now we have to go back to the laws of exponents and see, do I have any like bases here? And obviously I don't. So I'm just going to keep my x to the 6th the way that it is. So I have x to the 6th, and then I have multiplied by w to the 4th. So I have a w to the 4th. So I'm going to treat it the same way. I'm going to go off to the side, and I'm going to go ahead and do a little bit of simplifying of this big radical with variables. Luckily, we know how to do this from the second section of the unit. And I want to figure out what are my factors of 26. So I'm going to go in there and see if I have anything that's going to work here. So 26 divided by x doesn't look like it's going to give me much, to be honest with you. So it looks like 26 is already simplified. So I'm just going to keep him as is, and I'm going to rewrite him. And now my x to the 6. Oh, I'm sorry, if this is bothering you, I put a little division symbol. I'll take that away. Okay. So now I have x to the 6th, and I have w to the 4th to deal with. So I have 26, and then x to the 6th, if you remember how to simplify that, that's going to be x cubed. And then my w to the 4th, that's going to be my w squared. So I'm going to piece it all together now. And so now I have x cubed w squared root 26. And I'm going to take that and I'm going to replace my numerator. So I'm going to have x squared w squared root 26 divided by w to the 4th. So I'm not quite done yet, because if you remember from the laws of exponents, I have a w squared in the numerator and the w to the 4th in the denominator. So I need to do some simplifying. So I'm going to do this in 2 steps here. I know that x squared is happy the way he is. But when I take w squared and I say 2 minus 4, that's going to give me w to the negative 2nd power, followed by a root 26, all over 1. Now I need to make that w happy, and I'm going to say x squared in the numerator, root 26, and I'm going to bump my w down and square him in the denominator to give me my final answer. Okay, last one here. Let's go ahead and rationalize the denominator here. Now, this is a unique one because I have a 4 coefficient outside of my radical. That is not part of my radical, so I am only going to multiply by the radical. So I'm going to multiply the numerator and the denominator by 2a cubed. Okay, now let's go ahead and simplify. All right, in my numerator, I'm going to multiply, and I'm going to get 2 root 2a cubed. In my denominator, this is kind of a tricky concept, so try to follow along here. Let me erase these guys. So what I'm going to do is really multiplying this chunk by this chunk. And to do that, I'm really taking 4 times the coefficient of 1, so that's going to give me 4. Now, when I multiply root 2a cubed and 2a cubed, remember, I'm basically taking those radicals away. So really, I'm just left with 2a cubed. But I still have that 4 out front. So you have to remember that you're going to be multiplying those together, because that's the operation between them. So now let's go ahead and just simplify this down a little bit. So in the numerator, I have 2 root 2a cubed, and my denominator, I have 8a cubed. So at this point, I'm going to go ahead and I'm going to take my numerator, and I'm going to take them off to the side, and I'm going to go ahead and simplify what I can. So this is going to break into 2 times root 2 times root a cubed. So 2 and root 2 stay the same, but I know that a cubed is going to turn into a root a. So I'm going to put everything back together now. So 2a root 2a. And I'm going to take that and I'm going to substitute him back in for my numerator. So I have 2a root 2a divided by 8a cubed. So you got it. We have to do some simplifying now. I'm going to start with my coefficients. So 2 divided by 8, that's going to leave me with a 1/4. And then I notice that I have an a, and I have a cubed at the bottom. So you can recognize that I just have 1 up top, which is going to leave me 2 in the denominator, or you can do it in 2 steps. I'm going to do it in 2 steps. So I'm going to take 1 minus 3. That's going to give me a to the negative 2, followed by 2a under a radical. And then I'm just going to finish it off, and I'm going to say, okay, 4, I'm going to bring my a squared down, and in the numerator, I'm going to be left with 2a. And everything is simplified up to that point, so you are finished. All right, that's the lesson on rationalizing the denominator, and we're going to be working with some higher level, higher order variables in the weeks to come.